So last time when we talked about vectors, we talked about them in the standard way, which is that a vector is a quantity that has a magnitude and a direction. Okay? This time we're going to take that, I'm going to give a slightly different definition, a more functional definition. So I'm going to say that a vector v is just a collection of numbers, v1, v2, v3, all the way up to vn. Okay, and this n is the dimension of the vector. Okay, so for example, in 3 dimensions, this would just be vx, vy, and vz. Right, so we have 3 components, so that's 3 dimensions. If I just gave you 2 components, vx and vy, that would be two dimensions. And pretty much all the vectors we're going to use in this class are going to be either 3-dimensional or 2-dimensional. I don't think we're really going to use anything higher. Okay. Now notice when I wrote the vector v, I drew this funny little arrow thing above it. This is just a notation that we use so that we know we're talking about a vector as opposed to a scalar. So typically, whenever I write things on the board, and when you see them in your book too, anything that doesn't have this arrow, if it's just a variable, you can assume that it's a scalar. Whereas if we draw this little arrow on it, it means it's a vector. So these scalars that make up the vector, this vx, vy, and vz, so these we just call the components. So they're the scalar components that make up the vector. Okay? So another notation that's commonly used is we can write a vector as vx, x hat, vy, y hat, plus vz, z hat. Now don't worry too much about what these actually mean. We call them unit vectors, and in about 2 or 3 modules from now we're gonna talk about that in detail. But for now you can just think about them as directions. Okay, so again we have this vx, which is the same x component as before. We have this vy, which is the same y component as before, and we have this vz, which is in the z component. This notation is a little bit more clear because now this is letting you know that the first component is in the x direction, the second component's in the y direction, and the third component's in the z direction. So you notice I'm talking about directions here. So we can also actually represent a vector graphically. So if we call this the z direction, this would be the x direction, and up would be the y direction. And now we'll draw our vector v. Okay? And so what we can do is what we call projecting it. So we can project this down. So say it lands at a point here. Okay? This height would be the y component, vy. Okay? If we look over here, this would be vz. This is the component in the z direction. And so then that means that this part of the vector over here, from here to there, is vx. So this gives us a graphical way. It's a little bit easier if we look at this in 2 dimensions, right? Because in 2 dimensions, all we have is an x direction and a y direction. Right, so here it's easy to see that this is the vy, the y component, and this is vx, the x component. Okay, so and then there's one other way that we can represent a vector, which is we can instead of writing it horizontally like this, we can write it vertically. So we would have vx, vy, vz. So it's the same thing, only now instead of writing it horizontally separated by commas, we just have the different components written vertically. And so you'll notice in your book we'll use all 4 different notations, and each one actually has its advantages. So it's going to be very common, depending on what our application is, which of these we're actually using. But before we end the lecture, let's give another example, just so you can see with actual numbers the type of thing that we're talking about. Okay. So we'll look again at a two-dimensional vector. So we'll have an x direction and a y direction, and then we'll have our vector v. Okay. Now we notice if we look, again, this is going to be our y component, and this is going to be our x component. Okay. So for example, we'll say that that v is going to be 4 meters a second in the x direction and 3 meters per second in the y direction. Okay, or in other words, this is going to be 4 meters per second x hat plus 3 meters per second y hat. Okay. Now you remember before when we were initially talking about vectors, we talked about having scalars, right? And we said that the vector had a magnitude that was a scalar and a direction. So where's the magnitude in all this component form? Well, the magnitude, which we write like this, if we square it, we get vx squared plus vy squared, right? So the magnitude is just the length of this vector, and we're using Pythagorean's theorem, where the magnitude of v squared is equal to vy squared plus vx squared. So that's where we get this from. So the magnitude is just the square root of vx squared plus vy squared. Okay. Now what about the direction? Right, where's the direction in all this? Well, the direction actually comes from the components, right? This 4 is in the x direction, this 3 is in the y direction. Okay, so for example, let's say I cut the x component in half. Okay, if I do that, then I would have a new vector that went to here. We'll call it v prime. And so you notice that the angle that we make is different. Right, and this angle is the direction of the vector. Okay, similarly, I could keep x the same. I could cut y in half, right? And so we'll have v double prime, and now again, this one has a third angle that's different. So by changing the x and y components, we see that we can change both the magnitude and the direction of the vector. So that's going to be it for this lecture. Next time we're gonna actually start using vectors now. So hopefully you've got a good idea of what a vector is and how we write it and represent it. So now it's time to start seeing why these things are useful.